and there is a force of attraction on this mass m1 due to m2, like this. Force on mass m1 due to m2, and there is a force of attraction on mass 2 by 1. Okay, so this force will always be the central force. This force will always act along the line joining the two masses, not like this. This force cannot be like this, okay, or like this, not like this, okay. Always this force will act along the line joining the two masses. So the expression for the force is given by F is equal to G m1 m2 divided by, and suppose there is a distance between the two masses, okay. R is the distance, and right here R is the distance between two masses, so it will be R square, and the value of G is 6.67 into 10 to the power minus 11 Newton meter square per kg square. I think you know this fact already. And this G is known as universal gravitational constant. Universal gravitational constant. Okay. So basically this is a force. F is equal to G into product of the masses divided by the R square. This is the force between two masses. Okay. Okay. So point number one. Point number one is this force is a central force. This force is a center force. Number two, center force means this force always act along the line joining the two masses, line joining the center of two masses, okay? And this is always attractive force. Why I am telling this is the attractive force, because when you will go in your 12th class, in the very first chapter, you will study there like this, there is a law, Coulomb's law. So basically there is also the force of attraction or force of repulsion between the two charges. So force between the two charges can be repulsive also, but force between the two masses, okay, due to the masses, always attractive, or you can say gravitational force always attractive, okay. And there you will study the electrostatic force. Electrostatic force can be attractive, can be repulsive between two charges. Point number third. This force is independent of medium. Okay. Force is independent of medium. So what is the meaning of this? Suppose these are two masses, these two masses are in air. Suppose you have placed something in between these two masses. Suppose you have placed something in between these two masses, some object or suppose you have filled some material in between these two masses. So the magnitude of the force will remain same. Okay, this force will not be affected by the medium. Okay, okay. Point number fourth. These forces are equal and opposite. Okay, this force and this force on mass 1 due to mass 2 is equal to the force on mass 1 due to mass force on mass 2 due to mass 1, and they are opposite, they are in opposite direction, so they are equal and opposite. So we can write force on mass 1 due to 2 is equal to minus of force on mass 2 due to mass 1. And this formula is valid for point masses only. Okay, so you can write valid for point masses. Okay, so so these are the points. Okay, F is equal to G, you have to remember this, F is equal to G m1 m2 divided by R square. Okay, for example, you can take, suppose here is a mass of 5 kg and here is a mass of 2 kg. Okay, they both are separated by a distance of 10 meter. Okay, and you have to find the force of attraction or gravitational force between two masses. Okay, F, gravitational force. So it will be F is equal to G into m1 m2 divided by R square. So it will become G is 6.67 into 10 to the power minus 11. M1 is 5, M2 is 2. R square means 10 square. And you will get the value in Newton. The unit of force is, SI unit of force is Newton. Now next question. Suppose this is a mass and there is another mass like this. Oh. These two masses are in contact. These two masses are in contact and they are identical masses and they are identical spherical walls. These are identical spherical walls. Of radius small r, of radius small r, made up of same material, made up of same material. The force of gravitation between them is F and is F. So you have to tell that four options are given. Option A, this force is proportional to 1 upon r square. Option B, this force is proportional to r square. This C option, force is proportional to 1 upon r to the power 4. D, this force F is proportional to 1 upon means force is proportional to r to the power 4. So this you have to tell. Okay, these are two masses, okay, are in contact and this is the center and this will be the radius r. This is the center and this will be the radius. So we have to tell how the force will vary with the radius or with the distance. Can you tell me, anyone? Divyangi? A option. Hiba?
A.
This is not true. A option will be true when, you can see here. I know that you will tell A. This will be true when masses are given. Okay. When masses are given means this is G, this is M1, M2. So basically, you know what is the statement? Newton said that force of attraction is that is proportional to the product of masses M1, M2. Second statement was force is proportional to 1 upon r square. So basically, this is the inverse square law. Force is inversely proportional to r square. But here masses are also included. Okay, when you write this formula, you take into consideration m1 m2 by r square. You are taking in consideration the masses also. But there the masses are not given. You have to calculate the masses. Basically, what I want to say, the expression of masses, or you can say the mass can be mass is also depending upon the radius. Means mass can also depend upon radius. Okay, this is the formula I know. You can say force is inversely proportional to r square, but their mass is not given. So when you will put the masses, the value of the masses, maybe the value of masses is depending upon r. When the value of the masses will depend upon r, the proportionality will change with respect to force. You will see there. Okay, so identical. These are identical masses. Identical masses. Okay. So identical masses. So if identical masses, so we can say that the mass is m, this mass is also m. You can say let this is having a mass m, this is also having a mass m. Same material means density will be same. So suppose rho is the density. So rho is the density of this, rho is the density. Density will also be same because the material is same. Okay, because the material is same. Okay. Now for this we will calculate what will be the value of mass. Okay, for this what will be the value of mass. So this will be m, this will also be m. So we know that mass is equal to volume into density. Mass is equal to volume into density. Density is equal to mass upon volume na. So from there density is equal to mass divided by volume. Okay, so from here mass can be written as density into volume. So we will calculate the mass m. So mass m is density. What will be the volume of this sphere? 4 by 3 pi r cube. 4 by 3 pi r cube. Now you can see mass is depending upon the radius. So the proportionality will change here. So this is m, this is also m, so both masses will be same. So now you can write the expression for the force. What is the expression for the force? F is equal to g into m1 mass, m2 mass divided by the distance r square. Okay, so it will be F is equal to g. G is always constant. Mass, this is the mass m. Okay, so you can write it is m. First mass is m, second mass is also m. And what is the distance between the center of line? What I told you about the distance? You will take the distance from the center of the two masses. Okay, so r and r, 2r square, and this will become g into m. What is m? M is density rho into 4 upon 3 pi r cube. Density into 4 upon 3 pi r cube, and again multiplied by same thing, density into 4 upon 3 pi r cube. Okay, divided by 2r square. This will be square. So 2r and square of this. So what we will get? So we will get g into rho square. G into rho square, because this is rho and this is rho. 4 by 3 square pi square and r to the power 6, because this is r3 and r3, r to the power 6. And in denominator what we have? In denominator we have 4r square. Okay, now this r square is cancel out with this, so it will be r to the power 4. So now you can see this g is constant because this is universal gravitational constant. Density is constant. This is also constant, this is also constant, and this is also constant. So force is depending upon r to the power 4. What is the answer? D answer. Okay. So they will not give you the question like two masses are there. One mass is 5 kg, another mass is 3 kg. That question you solved in your ninth class. Okay. Now you will solve the questions like this. One more question. Hmm. This distance is L. This is L. This is L. Oh, sorry. This is 2L. Okay. This is 2L. And this is mass M. And this is mass 2M. This have mass M. This have mass 2M. They are asking, find the gravitational force between them, between masses. Gravitational force between masses. Solve it. Both of you use the formula F is equal to G M1 M2 divided by R square and tell me the answer first. And always remember, this is a central force. Completed? Hiba, completed?
No, sir.
What is the answer? You did like this, na? F is equal to G into M into 2M divided by L square. So 2G M square by L square. This is the answer, na?
So we should expand for
Hmm.
D.
We should? No.
0.67
You can, no need. You have to, you can write our answer in this form also.
Okay.
So basically, if you are doing like this, so this is wrong answer. Okay. Now see how we will solve this question. Basically, what I told you, always the force will be along the line joining the center of two masses. Center of two masses. So first see what is the line joining center of two masses. So this will be the center of, basically this is L. So basically this will be the center of this mass. Fine. But can this be the center of this mass? No. Center of this mass will be somewhere here. So if you will find the center of this mass, so center of this mass will be somewhere here, and which is at a distance of L by 2 or not. So this center will be at a distance of L by 2, or you can say if you will measure the distance from here, then you can say it is at a distance of L by 2. Okay. So this center is at a distance of L by 2. Basically, this distance is required. Basically, this distance is required. This.
So,
Yeah.
how did you get L by 2?
Why? How I get L by 2? Because this, you can see this figure. This figure. Okay. So L by 2, this whole length is 2L. Okay. This whole, oh sorry, this is not L by 2. This is
L.
L. Yeah, this is L. Sorry. So it will be L. Okay. Understanding now why L? Because the center of this will be at a half distance L. Okay. From bottom or from top. So it will be at L. Okay. Fine. It will be at L. So, and for finding the force, this will be your R. Okay. Now this becomes a triangle. Okay. This distance is R. This distance in this triangle, this distance is L. Now what will be this distance? Can anyone tell me what will be this distance? This whole distance is L. Divyangi, tell me what will be this distance?
L by 2.
Yeah, L by 2. Because you can see this is the center of this. So this distance is L by 2 now. So this is a parallel line. So this distance will also be L by 2. Okay. So if this distance is L by 2 and this whole distance is L, so L minus L by 2 become L by 2. So I am removing this because diagram will become very dirty. Okay, so this distance is L by 2. So basically we can take this triangle out. So this angle is 90 degree because this angle is 90 degree. Okay, so and this is R you want to find, and this is L by 2 and this is L. So you can apply the Pythagoras theorem. So it will become R square is equal to L square plus L by 2 square. So it will become L square plus L square by 4. So what it will become? It will become 5L square by 4. 5L square by 4. Okay. So from here you will get R you will get as root 5 by 2 and L. This R you will get now. You have mass M1, M2, you have R, you can find the value of force. F is equal to Gm1 M2 divided by R square Gm1. M1 is M, M2 is 2M. And what is the central distance? This is the central distance, not this central distance. So it will be root 5 divided by 2 into L and a square of it. So it will become 4G into 2M square. Are you getting now why I have written 4? Yeah, I am solving like this. So you can see this will be 2G into M square. It will be 5L square. and divided by 2 to the 4. So it will become 8 g m square divided by 5l square. So this will be the final answer. Okay, this will be the final answer. This is a good question. You have to remember, you will always take the distance between the center of two masses always. Okay, write down. Okay. Done. Okay. Done. Completed. Hiba completed. Divyangi completed. Okay. So now we will move to the next topic, principle of superposition. This principle of superposition you will study in your 12th class also. Okay. So basically, what is principle of superposition? See, suppose this is mass m1, this is mass m2, mass m3, m4, okay, m5, m6, m m5, m6, and there are n number of masses are there. There are n number of masses are there. So now choose mass m1 and see what are the what is the total force of choose mass m1 and see what is the total force of mass m1 due to individual masses m2, m3, m4, m5, m6 and mn, and add these forces vectorically. Okay, suppose for example, suppose this is just the example on this mass m1, so we should take the mass m1 here. Suppose due to this I will take this is m4 should be here, or this is m3 and m2 should be here. See, okay, so okay, now it's fine. Now this is m1. So on this m1, what will be the force due to m2? The force due to m2 will be this force on mass 1 due to 2, and force is along the line joining the two masses, line joining the center of two masses. This will be f1, f2, f12, okay, and write it at vector. Now force on mass m1 due to m3 will be this, means will be like this. Force on mass 1 due to 3 in this direction, means on this mass m, f12, and suppose take mass m4, suppose mass m4 is here, okay. Now force due to mass m1, uh, force on mass m1 due to mass m4, suppose is this f, force on mass 1 due to mass force due to mass 4 is like this, and so on, okay. There will be the force on mass m1 due to mass m5 also. There will be the force on mass m1 due to m6, and number of masses are there. So what you will do for calculating the net force on mass m1, net force on mass m1, what you will do, you will do the vector summation. Force on mass m1 due to mass 2 plus force on mass m1 due to mass 3 plus force on mass m1 due to mass 4, and so on, and calculate it for other masses also. Force on mass m, force on mass 1 due to nth mass. So basically this is the principle of superposition in simple words. So on this means what we are doing, we are calculating the total force on mass m1 due to other individual masses, and we are doing the vector summation of those forces. Okay, one question. This is the equilateral triangle. So here M, here is M, and here is M. Three equal masses are placed at the vertices of an equilateral triangle of side A. Okay. We have to find the total force on this mass M. Total force on this mass M. Suppose this mass M you can take as mass 1. This is 2. This is 3. Okay. So find net force on mass at A. So suppose this edge, this vertices is A, and this is B, and this is C. Okay. Okay, so no need to write this. On mass M1. Okay, so we have to calculate the force, total force on this mass M. So on this mass M, the force will be due to this mass and due to this mass. So first we will find the direction of the force. Okay, so on this mass M, the force due to this mass will be along this line because this is the line joining between the center of the two masses. So it will be like this, and this mass M will attract this mass. So direction of the force will be like this. This you can say this is force on mass 1 due to mass 2. Due to mass 2. Now on this mass M, the force due to this will be in this direction. Force on mass 1 due to mass at 3. Okay. And this is the equilateral triangle. So this angle will be 60 degree. This is the equilateral triangle. So this angle will be 60 degree. Okay. Now total force on mass M, will be the vector summation of F1 plus F12 plus F13. So you can say the net force on mass M1 is the vector summation of F12 plus F13. So first find what is F12 and what is F13. Okay. So F12. First find the magnitude of F12. So it will be G into M1 M2 divided by this distance square. So it will become G into M divided by A square. So it will be Gm square divided by A square. Now same force will be due to mass because this mass is M, this mass is M. So on this mass, both the forces will be same. So you can see from the formula also. So it will also G into M divided by A square. So it will be G into M square divided by A square. Okay. So now you can draw this. Suppose this is mass M1 and one force is in this direction, F12, and another force is in this direction, F13. Okay, and both forces are equal. You can see F12 and F13 are equal. So suppose this force is F and this force is also F. So you can say that this F12 can be written as F and this F13 also can be written as F, and this angle is 60 degree. So can you find the resultant with the vector? The net force on mass m1 is given by under root of f square, means a square plus b square plus 2ab sine cos 60. So it will become f is f. It will become f square plus another f square plus 2 1f1 plus another f1, means it will become f square, and cos 60, and cos 60 is 1 by 2. 1 by 2 and 2 will cancel out, f square f square f square, it will become root 3f. So net force on mass m1 is root 3f. So root 3, and what is the value of f? G m square by a square. G m square by a square. So this will be the net force on mass m1. Magnitude. This is the magnitude. Direction we can find, because these are two vectors, so direction resultant vector will be in between. We can find that also, but here that is not asked. They have not asked that. So basically the resultant will be from the middle. Okay, this angle is 60 degree, so resultant will be like this, net force, because symmetrical condition is there, so this angle will be 30 degree, this angle will also be 30 degree. So this will be the direction. Okay, talking about the direction, so direction will be, this will be the net force. Okay, so diagram will look dirty, so I am removing that. Understanding, Hiba and Divyangi?
Yes, sir. Yes.
We have to find in this question the net force on this mass m. So on this mass m, there will be a force due to this, and there will be a force due to this mass, and we will see what will be the direction of both the forces. And force is a vector quantity, so we can use the vector laws to add both the forces, and this is from the superposition principle. Okay, so note down. Write down fast. Okay. Hiba completed?
Done, sir.
Okay. This is an equilateral triangle. You can see all sides are equal, so it will be an equilateral triangle, and all angles also will be 60 degree in equilateral triangle.
So,
Yeah.
where do we use superposition principle in this?
So we have used superposition principle in this because if there will be more than uh, one mass, means if there is this mass and only this mass, okay, if there is this mass and only this mass and no this mass, so in that case you can find the value of the force on this mass by g m1 m2 by r square. There is only one force, but here is another mass also present. So due to this mass also there will be another force. And so what will be the condition? One force on this mass is in this direction and one force on this mass is in this direction. And basically adding the forces vectorically is superposition principle. Superposition principle is nothing. Okay? Superposition principle is nothing. But adding the forces vectorically. Suppose for example, wait. If suppose this is mass m1, if I am saying one force f1 is in this direction, another force f2 is in this direction, okay, and another force f3 is in this direction at an angle of 30 degree, another force f4 is in this direction at an angle of 60 degree. So when you will calculate, okay, suppose this is f1 and this is f2 like this, you can write in vector form f3 and f4. So on this mass m, there are four forces acting in different direction. So if I say that, what is the net force? If I say that, what is the net force on this mass m? So what will you do in that case? You will do the vector summation, na? Then you will get the net force. You will do the vector summation, then only you will get the net force, na, on this mass m. Is it or not? So superposition principle is nothing but adding the forces vectorically on a particular mass. Okay? Okay, write down. Completed?
Yes, sir.
Okay, Hiba and Dibyangi, so time is up now. We will meet in the next class. Okay, so revise your notes, whatever we did and whatever you are studying. Okay, so we will meet in the next class now.
Thank you, sir.
Okay, fine.
Sir,
Yeah.
do I have class on weekdays other than Tuesday and Thursday?
What are you saying?
Do I have class on weekdays other than Tuesday and Thursday?
So today is the Saturday, na?
Yeah.
So it is a weekday.
No.
So on Sunday you are saying?
From Monday.
Yeah, from Monday you will have the class, means on the same days, means Tuesday and Thursday and Saturday.
Yeah. Okay, so I have extra class after this, so I'm asking.
You are having an extra class of which subject?
Physics.
With any other teacher?
Yeah.
Yeah, I think it will be. Okay. I
Okay.
think it will be.